In the space exploration era, humanity has made a significant breakthrough. The solar system is no longer an unexplored region. Numerous Earth-based probes confidently explore its vastness, visiting planets or passing in close proximity. Jupiter, our closest giant neighbor, has received considerable attention. Landing on its surface is impossible, however, as the celestial body lacks a solid surface. Therefore, missions are categorized into orbital, atmospheric, and flyby missions. Flyby missions involve a spacecraft passing near the planet. The majority of Jupiter missions to date have been of this type, at least 7. Studying Jupiter presents numerous challenges, including the intense radiation emitted by the planet. This necessitates extremely careful probe design and construction. The pioneering exploration of this solar system giant was undertaken by the Pioneer 10 probe. It was the first to approach Jupiter. Subsequent probe designs incorporated lessons learned from Pioneer 10's operational issues. What did Pioneer 10 discover in Jupiter's vicinity? It lived up to its name, providing the first close-up images of Jupiter's Galilean moons in 1973, achieving a scale of imaging previously unattainable. The probe also partially studied Jupiter's upper atmosphere, identifying its powerful magnetic and radiation belts. A year later, Pioneer 11, a next-generation spacecraft, accomplished a feat long dreamed of by Earth's astronomers. Flying at an altitude of 34,000 kilometers above Jupiter's swirling clouds, it photographed the Great Red Spot, revealing the monstrous vortex in detail. This hurricane has been raging for at least 350 years, the duration of its observation by scientists. While it's gradually shrinking, the vortex is still large enough to easily contain 2 or 3 Earths, or 78 Mercuries. Wind speeds inside reach 500 kilometers per hour. The spot's persistent red color is due to the presence of phosphorus in the atmosphere. In addition to the Great Red Spot, Pioneer 11 observed Jupiter's polar regions and determined the mass of its moon Callisto. Voyager 1 later conducted a brief study of Jupiter, examining its rings and moons and adding to the data on its radiation and magnetic fields. Notably, if not for Voyager, the world wouldn't know that Jupiter possesses rings, albeit less impressive than Saturn's. The Voyager probes also first detected significant volcanic activity on Io, a moon of Jupiter. Previously, such activity was believed to be limited to Earth. Crucially, the images and data obtained from these missions led to the hypothesis that a vast, potentially habitable ocean exists beneath the ice of Europa, another Jovian moon. In 2000, the Cassini probe passed near the gas giant, transmitting over 26,000 high-quality, detailed images of Jupiter. This allowed scientists to observe objects as small as 60 kilometers across. Most famous among these is a remarkably clear image of Jupiter's pole, unprecedented in quality. In 2007, the New Horizons probe made a flyby of Jupiter en route to Pluto. Among other observations, it studied the Great Red Spot, noting that its color and other characteristics resemble other, smaller storms observed in Jupiter's atmosphere. Regarding orbital missions, only 2 have been completed so far, Galileo and Juno. Galileo entered Jupiter's orbit in December 1995 and remained there for 7 years before being destroyed by the planet's atmosphere. A key event during its mission was the observation of the impact of comet Shoemaker-Levy 9 in 1994. Observing this collision from Earth was impossible, highlighting the value of Galileo's images. From July 16th to 22nd, the probe witnessed the fragments of the comet plunging into Jupiter's atmosphere. The fireball temperature resulting from the impacts reached 20,372 degrees Celsius, far exceeding the -140 degrees Celsius of Jupiter's upper atmosphere. The explosive plumes from the cometary fragments soared 3,000 kilometers high. This was the first extraterrestrial collision observed in such detail. Another pioneering feat of Galileo was deploying a probe into Jupiter's atmosphere. The probe descended for approximately an hour, covering 156 kilometers of the turbulent layers before being crushed by the immense pressure and heat. It is likely that the probe subsequently vaporized in the deeper, hotter layers. This remains the only atmospheric probe mission to Jupiter, making the acquired data invaluable. Juno has been orbiting Jupiter since 2016. To achieve a record low orbit of 4,200 kilometers above the cloud tops, It used a 30-minute engine burn upon approach. Juno aims to determine whether Jupiter possesses a rocky core and to measure the abundance of water in its atmosphere. The data should provide insights into the planet's formation. In 2021, Juno is expected to meet the same fate as Galileo. Future missions are planned, most notably the NASA Europa Clipper mission, tentatively slated for launch in the 2020s. This mission includes the possibility of landing on the Galilean moons. Even further in the future, crewed missions to Jupiter are envisioned. A potential landing site is Callisto, where the deadly radiation is less intense. Europa is not a prime target for crewed landing because the radiation levels are too high and currently available technology isn't sufficient for astronaut protection.